For 3.7, we are doing rational functions. So a rational function you have graphed before. So let's have our attention up here. Okay, our rational functions are going to be graphed with asymptotes that we are going to find today. So you guys might remember us finding asymptotes previously in Algebra 2. Okay. Yeah, and then when you are finding these asymptotes, we're going to talk about the different rules. So really all of the rules you've heard before, and then we're just going to be looking at some different examples of how to apply them. So whenever you have this line, x equals a, and then is the vertical asymptote, and then y equals b is the horizontal asymptote. The best definition is going to be that an asymptote is a straight line. It can be horizontal, vertical, or slanted that the graph comes near. Okay, so a lot of times we think of an asymptote cannot be crossed. That is true if it's a vertical, but a graph can cross a horizontal asymptote. Again, you saw some of those examples in Algebra 2, and we're going to look at some of those examples again this year. Okay, and you do have to have your line notation if it is an asymptote. So the first thing we're going to talk about is vertical. So vertical asymptotes are the lines x equals some value, we'll call it a, and this is where that value of a is a 0 of the denominator. So we have to solve to find the zeros in the denominator. If it is a horizontal asymptote, then we're going to follow these rules. Okay, so the first rule is if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. If the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is the fraction formed by the leading coefficients. Okay, and we're going to write that out together. Looking at these rules, are they starting to seem familiar? Is something you remember from the past year? The degree of the numerator, and you're comparing that to the degree of the denominator. Okay, so when it's a fraction formed by the leading coefficients, it's the leading coefficient of the numerator that's going to go on top. And it's the leading coefficient of the denominator that's going to go on the bottom. Okay, and then you can simplify that if you need to. And the last one is if the degree of the numerator is greater than the degree of the denominator, and that means there is no horizontal asymptote. Okay, so to help me look at this quickly, I usually put numerator less than denominator. Numerator degree is equal to the denominator degree, and the numerator is greater than the denominator. That way I don't have to sift through all those words, but they're there to help you as you begin to practice those. Okay, so the first thing we're going to do, it just says to find all the horizontal and the vertical asymptotes if there are any. Okay, so sometimes there might not be one to find. So vertical is finding the zeros of the denominator, which means we are going to set the denominator equal to 0 and solve. Okay, so I'm going to have you guys go ahead and solve that. And then for step 2, I want you to find what rule that's going to be. Okay, so we're going to solve for the quadratic. All right, so when you factor, we should be setting this up so that it multiplies to 9x squared, so 3x and 3x. And then if it multiplies to a positive and adds to a negative, both of these have to be negative. So this would be negative 6 minus 3, that's negative 9. So you should be doing that guess and check, at least in your head, and writing it out if we need to. So x equals 2/3 and x equals 1/3. Those are going to be your vertical asymptotes. Remember, when you are writing your asymptotes, they need to be of this form because they are equations of lines. Okay, so this is the form for the vertical asymptote. And then the form would have to be y equals that value for the horizontal. So for the vertical, it has to be x equals. For the horizontal, y equals. Okay, so for step 2, you should have found that the degrees are equal. Degree is just the highest exponent, so they're both 2. So we're going to do the leading coefficient of the numerator over the leading coefficient of the denominator. So what's the leading coefficient of the numerator? So what's the leading coefficient? 1, yep. And then of the denominator, 9. So it would be 1/9. Maybe that would be your final. Okay, and then if this simplified, you would have to simplify it, right? If it was 9/9, it would be 1. Okay, so if it simplifies, we are going to do that. All right, and then for B and C, I'm going to have you guys use your rules, and I want you to write down the vertical asymptote and the horizontal. So do that for each one. Vertical and the horizontal. Okay, so use your rules. All right, and then we're going to check our work together. So the vertical asymptote for part B should be x is equal to 1, and the horizontal, there is none. Okay, I just put some additional things on there. You don't have to have those on there, but when you're comparing the degrees, it's 2 to 1. So the numerator is greater than the degree of the denominator. That's why there's none. Okay, and then we always set the denominator equal to 0 to find the vertical. Okay, for part C, you did have to factor. So when you factored, you should get x plus 4 and x minus 1. So when you solve, x equals negative 4 and x equals positive 1, those are going to be your vertical asymptotes. If you have a constant, the degree is 0. The degree of the denominator is 2, which means the numerator is less than the degree of the denominator. So y equals 0 is going to be the horizontal asymptote there. Okay, any questions for me on B and C? All right, let's review our steps for sketching the graph and finding the domain and the range. So the first thing we're going to do is we're going to factor the numerator and denominator if you need to. Then we're going to find the x and y intercepts. X-intercepts are zeros of the numerator, and when you are finding your y-intercept, you can just plug in 0 for the x value. Okay, you're also going to be able to use your graphing calculator so you can verify your intercepts with your table. That is fine. And then you're going to find the vertical asymptotes and the horizontal. So for vertical, always zeros of the denominator. Okay, for the horizontal, it says stated above, but it's really on the previous page. You're going to be using those rules. Okay, and then it says sketch the graph using intercepts and asymptotes. Make a table of values if needed. You can use the table on your calculator or on Desmos. Okay, so if you're planning on using Desmos, make sure that you practice with that. You can also use both. Okay, and then with the domain, that is going to be the possible x values. Okay, and we're going to be writing those in set builder notation. The range is going to be the y values, and there are several different cases for the range. So we're going to look at a few different graphs because the range is going to change. Okay, whenever you're working with the domain, the domain is going to exclude the vertical asymptotes, and we will write that down. Okay, so for the domain, x cannot be equal to, we'll put VA for now, and then we'll talk about that in our first example as well. Okay, so the directions in your book are going to say find the intercepts and asymptotes and then sketch a graph of the rational function, state the domain and range in set builder notation. You may use a graphing device to confirm. So either the calculator or Desmos is fine. And for step 1, you don't have to factor. One thing you might want to do is put the numerator in standard form. That's just going to help if you have to use the leading coefficients. And for this, the degrees are equal, so we are going to have to use that. Okay, so that's something to think about. And then when you're finding your x-intercepts, it is just the zeros of the numerator. So you can set the numerator equal to 0 and solve. So negative 3x plus 4 equals 0. Okay, so if you're going to solve, subtract 4, divide by negative 3. We know a negative divided by a negative is a positive. So then on our graph, 4/3 0 should be something that we see. Okay, so I'm just following along with my steps. X-intercepts the zeros of the numerator, set the numerator equal to 0, and solve. Okay, that's what we're doing. And then here it says plug in x equals 0 to find your y-intercept. So if you substitute in x is 0, okay, it doesn't matter if you use this one or this one. What you're going to have is y is equal to -3 times 0 plus 4 over 0 plus 7. All right, so then if you simplify that, you'll get 4/7. Okay, so 0, 4/7 is going to be your y-intercept. Moving on to step 3, where we're finding those vertical asymptotes, which is what you just practiced. You're going to set that denominator equal to 0. So you get x equals -7. Then we start thinking about that horizontal. What are the degrees? In this case, the degree of both is 1. So degrees are equal. So y is going to be the coefficient of the numerator, which because we put this in standard form, we're going to recognize as -3. And then the leading coefficient of the denominator is 1. So we do want to simplify that so that it is -3. Anything divided by 1 is going to be itself. And whenever you are graphing, you are going to want to label your asymptotes on your graphs. Okay, so we're going to make sure that we label those on all of our graphs. Okay, as we begin step 5, which is to sketch the graph, we're going to use our graphing calculator to help us come up with some good points to graph. When you are graphing, just remember you are going to need to see all branches of the rational function. Okay, so at the very least, the rational function is going to have 2 branches. Sometimes it has 3. Okay, you may remember when we graphed these earlier, a rational function, the name of it is a hyperbola. So it's going to have more than 1 branch. You can either put this in standard form or you can put it in as the original, but whenever you graph a rational function, okay, if you have a binomial or larger, those have to go in parentheses. Okay, so you're either typing that into decimals at this time or you are putting that into your graphing calculator, and then we are going to be checking out the graph. Okay, so with your first window that you go to, right, because we're in the standard window, I can only see 1 branch, okay? I need to see at least 2 of them. If you guys want to go to zoom and then 3 is zoom out, okay, now you can see both branches here. So we are going to have to make sure that we see both of those. All right, so I'm going to look at my table now, and as I'm looking at my table, I can see at -6, I'm at 22, so I'm definitely going to want to go by 2's on my y's. Why do I have an error at -7? That's because that's going to be your what? Yeah. It's the asymptote, right? Because the denominator is 0, that's what creates the asymptote. That is where you should see your error, and that's a good way to double check that you have the correct function in there. So we already know a few of our points. We know at 0, we're at 4/7. That's going to be something that we'll estimate. Okay, you can use the 4/3 and the 0 there, and then I'm just going to look at some of my values on the positive side to see what's happening. So it looks like at 3, I'm at negative 0.5. So I'm going to try to graph that. And then all of these are really close together. I think at 13, I'm at negative 1.75. Looks like at 18, I'm at negative 2. Okay, so based on what I'm seeing here, I'm going to want to label both of these by 2 because you were given a 10 by 10 grid. So this would be 2, 4, 6, 8, 10, 12, 14, 16, 18. 2, 4, 6, 8, 10, 12, 14, 16, negative 18. And negative 2, I'm at 2. And yeah, negative 6, I'm at 22. Okay, so I'm using this to help me set up my graph. I'm also going to want to put in those asymptotes the first thing before I start doing points. So 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, and you just have to give an indication of what your scale is. I put a little more in because I like that as I'm graphing. Okay, and then we are going to be labeling our asymptotes. So that should be the first thing you put in when you are ready to graph. So we have one at negative 7. So x equals negative 7 is what I'm going to label. And then I have negative 3. So if this is 2, then negative 3 is going to be right in the middle here. Okay, and then I just want to make sure that I'm doing a nice job graphing each branch that I have. So at 0, I'm at 4/7, so that would be about halfway there. 2, so this would be 3, negative 1/2. At 18, I'm at negative 2. At negative 2, I'm at 2. At negative 6, I'm at 22. So I might want to see what happens at negative 5. So at negative 5, I'm at 9.5. So about here. So I want enough so that I can see what this shape is. Right, so I'm just going to create my curve here. And I usually do this with pencil so that if I accidentally go over this, I can change it, or if I don't like that that looks like a bump in the road, I can just make that smoother. No, the green ink has bled onto my eraser. All right, and then I do need to see what happens over here. So I'm going to need some points that are past negative 7. Okay, so at negative 8, I'm at negative 28. Sometimes what's helpful as well is to see like some of the halfway points. At negative 9, so this is 8, so at negative 9, I'm at 15.5. Negative 12, I'm at negative 8. 2, 4, 6, 8. Then let's see what's happening at negative 18. Negative 17 is 5.5, so that's pretty good. 2, 4, 5.5. Okay, so I just want enough points so that when I graph this, it's accurate. Okay, so I can get a good curve in there. Okay, and you can use those points from your table to get that curve. Once you have graphed that for part B, I want you to do the first. Oh, wait, we're not done yet. 5. Step 5, but there are 6 steps because the last step is the domain and the range. Okay, so the 6th step for the domain is x such that, and then like we said, x cannot be those vertical asymptotes. So in this case, the vertical asymptote was just -7. So it's just x cannot be -7. That's what, it's a fraction, right? It's whatever makes the denominator 0. So for all of the domains, it's going to be x cannot equal the vertical asymptote. Okay, the range is the one that's going to vary. Okay, so if you have 2 branches like this hyperbola here, okay, it is just going to be y cannot equal the horizontal asymptotes. Okay, and that's just for this case. So that's why I'm going to specify that. For this case, y cannot equal the horizontal. But we're going to see some different cases here. Okay, so in this case, it's getting really, really close to -3, the asymptote in both directions, but it is not crossing it, so it cannot be that value. Okay, and we're going to be able to determine the different cases by looking at these different graphs. I call this one the baseball seams, so it looks like baseball seams from here. You were to draw your baseball in there. Y cannot be the horizontal. Okay, so for B, I want you to do steps 1 through 4. Okay, so factoring, except I'm going to have you skip the x-intercept. We'll do that one together. So I want you to do step 1 where you're going to factor the denominator. You don't need to factor the numerator. For the x-intercept, I'm going to help you with that. The y-intercept, you can do without me. The vertical asymptote, you can do that without me. Horizontal, you know how to do that. All right, so let's check that you factored correctly. X plus 1 and x minus 6. Okay, and then you found your x-intercept. Remember the y-intercept. For the y-intercept, you're just plugging in x is equal to 0. So when that happens, you get 6 over negative 6. What does that reduce to? Negative 1. Good. So you guys should have written down your y-intercept as 0, negative 1. Okay, now for the vertical, you are just going to take your two values from your denominator, set them equal to 0, and solve. So if you set x plus 1 equal to 0, you get x is negative 1. Okay, x minus 6 is going to give you x equals 6. And then for horizontal, compare the degrees. So the degree of the numerator is 0. The degree of the denominator is 2. So the numerator degree is less than the denominator degree, which means the horizontal is going to be y equals 0. Okay, the x-intercept, which I said we were going to do together, is where you set the numerator equal to 0 and you solve, right? They're the zeros of the numerator. But in this case, your numerator is just 6. So if you set that equal to 0, you can't solve for x. So when that happens, there is no x-intercept. Okay, no x-intercept in that case. All right, so then for step 5, for our chart, we are going to be graphing. So we're going to go back here, and then because the numerator is just a monomial, you don't need parentheses around it, but the bottom is a trinomial, so we want to put the parentheses. Okay, you can graph it here. Let's see if it fits in a 10 by 10 window. So I'm going to go to zoom back to my standard. Yep, I can see all of my branches in the 10 by 10, which means I'm going to scale this by ones. And then when that happens, I like to put in my asymptotes right away. So we have x is equal to negative 1. That's going to be a vertical asymptote, which we will label. And then 1, 2, 3, 4, 5, 6. One thing you will want to consider doing is putting your asymptotes in with highlighters if they are on the axis, just so that they show up a little bit better. So for y equals 0, I'm just going to highlight this so you can see it better. Remember that all of the asymptotes are going to be dashed lines to show that they are not the actual curve of the graph, they are just those asymptotes. So I want to have some values in each branch of the graph. And the y-intercept is 0, negative 1. So if you wanted to put that in right away, you can. And then I also like to do this with pencil in case something happens. Okay, so I know 0, negative 1, that's going to be part of this branch in the middle. So if I go to my table, whoopsies, sorry, going the wrong way. Okay, at 0, I'm at negative 1. It looks like at 2 and 3, I'm at negative 0.5. And at 5, I'm at negative 1. Okay, and then this is going to be just a very slight curve, and it's going to follow this asymptote down. It's going to follow this one down. It's a pretty broad curve that I have here. Okay, and then I need some values past 6. So at 7, I'm at 0.75. at 10, I'm really just close here. And then if you would like to, you can change your table set so that you're going by halves. If you want to see what happens in between 6 and 7 in this case, and then you have 1.6 there. Okay, so this is going to be going upward. We're just going to put that curve here. And then we want to see what's happening after -1. Okay, so at -1.5, you're at positive 1.6. You can see here it's getting closer and closer to 0. This is 0.1. Okay, so again, you are going to be curving this up. And it's going to be going along that asymptote. It is not going to cross that one. Okay, so your domain is always going to exclude your vertical asymptotes. If you have both, you can just say x is not -1, 6. That's fine. And then if you have a parabola here, when you are setting up your y values, it's going to be y is less than or equal to the maximum, or y is greater than that horizontal asymptote there. So we are going to have to find the maximum. Okay, so we're going to practice doing that on the graphing calculator. If you are doing that on Desmos, make sure you're clicking on the maximum, because you might be clicking on points to help you with your graph. Make sure you find your max value there. If you're using your graphing calculator, you just have to go to Second Calc, find the max, and it's asking me left bound. I'm going to make my bounds just all the way to the left and all the way to the right, so it will find the highest point in between those two, because this one is like a little bit flatter. Okay, so when you find it, it's -0.489, so we're going to round that to 2 decimal places. So it's y is less than or equal to -0.49, or y is greater than, in this case, 0. Okay, and then if you cannot find that for on Desmos, let me know. I'll come around and help you. And then again, I want you to do the first few steps on this. When you're factoring the denominator, I just want to remind you, you got to take out the GCF. So you got to take out the x there. Okay, so give those first 4 steps a try, and then we will graph it together. Okay, so if it multiplies to -6 but adds to -1, you have a -3 and a +2. When you take out the GCF, you get x times x plus 3, which means your x-intercepts are going to be the zeros of the numerator. You've already factored, so it's going to be 3 and -2. So we know 2 points on the graph already. 3, 0, and -2, 0. Now when you got to the y-intercept and you plugged in x was 0, on the top of the fraction you got -6, on the bottom you get 0. This is undefined. So if it's undefined, that means there's no y-intercept. Okay, there's no y-intercept. Okay, for the vertical, don't forget this x here. This is x equals 0. The other one is going to produce x equals -3. Okay, and then your degrees are equal. So the leading coefficient over the leading coefficient, 1 over 1 is y equals 1. Okay, and then we are ready to do our chart. And then I gave you a 5 by 5 grid because that's all you needed. Okay, when you're doing this on your own, if you want to do like a 10 by 10, that is fine. So we have x squared minus x minus 6 divided by x squared plus 3x. Okay, so this one you have 3 branches. Okay, so because you can fit this in the 5 by 5, we'll just go by ones. Again, I'm going to use just highlighters because I have x equals 0 here. So I want to make sure that stands out. Okay, and then I have x equals -3, 1, 2, -3. And then my y value is going to be 1. Okay, so I'm going to label those. I have x equals -3, I have x equals 0, and I have y is equal to 1. Okay, and then I already know I have 3, 0, so 1, 2, 3, 0. I have -2, 0. I can put those on my graph right away. And then I'm going to go to my table. So I need to see what's happening over here past x equals 0. Okay, so at 1, I have -1.5. And we already said at 3, we have 0. I want to see what's happening at 5. I can. It's 0.35. Okay, so this is going to help me with my curve here. Remember, this is never going to cross that asymptote. So I have 1 branch. And then I need to see what happens in between 0 and -3. Okay, so at -1, I'm at 2. And then I already have at -2, I'm at 0. So this is one where it's helpful to look at that. So I had -2, 0. It's going to be helpful to look at that -2.5. That's -2.2. Because you can see from the graph, we have like a cubic type function happening here, where this is just going to curve up a little this way. It's going to curve down some that way. And then I need to see what's happening past -3. So at -4, I'm at 3.5. At -5, I'm at 2.4. Okay, so I can curve this up here. All right, and then I'm going to do my domain and range. Okay, domain is the same, so you cannot have 0 or -3. The range, for this case, because you have this function here that goes to infinity and -infinity, your range is going to be all real numbers. Okay, so anytime you have a function that goes through the horizontal all the way up and all the way down, it's going to be all real numbers.